I'm Anil Kumar, and here are interesting questions on even and odd functions. Determine algebraically whether each function is even, odd, or neither. Justify your answer. I have purposely taken these two examples. On face of it, it looks like both are even functions. I'll show you algebraically and then also graphically that they are not even function. And let us try to understand why. First one, f of x equals to x minus 4 whole square. So to prove that this is an even or it is not an even function, we need to find f of minus x. So f of minus x will be minus x minus 4 whole square. Now you can take minus common, let me use square brackets, minus common. As soon as I take minus common, it becomes x plus 4 whole square. Now square of negative is positive, so what you get is x plus 4 whole square. As you can see, this is not equal to f of x, and it is also not equal to minus of f of x, right? That means the function is neither, right? So therefore we get that this function is neither. Now the question is, it looks like even. Why it is neither? So that is what you need to understand. So let us look at this function once again. So this time I'll kind of graph it for you. Now here x minus 4 whole square means the vertex is at x equals to 4, right? So x squared is a function which is kind of like this, right? This is x squared, which is even function. But x minus 4 whole square means it has shifted 4 units to right, correct? So now the function is kind of like this. As you can clearly see, since it has horizontally shifted, it is no more even. Line of symmetry has changed from y-axis to x equals to 4. Even functions will have line of symmetry as y-axis, right? So whenever a horizontal translation actually affects the symmetry for even functions, do you see? So horizontal translation affects symmetry. That is very important to understand. And in case original function, the parent function is even, if it's translated left or right, it is neither, since the line of symmetry has changed from y-axis to some other point, right? That is the reason. Now the second example is exactly same. With different, of course, function, but the concept is same. Here also you will observe that the absolute function has translated 2 units to right. Because of that, the symmetry is lost. Numerator is even, but denominator is not even, and therefore the function is not even. You can actually calculate g of minus x, which will be minus of minus x squared divided by absolute value of minus x minus 2. Now this is equal to minus of x squared. So the numerator is kind of same, right? But the denominator, as you can see, it becomes plus. It is x plus 2, not x minus 2. Just as we saw here, right? X minus 4 changed to x plus 4. And therefore, these two functions, as you can see, are not even. So that's kind of very important to understand. I've seen this as a common mistake in many test papers, so I like you to make a note and remember, if an even parent function translates horizontally, then it is no more even, right? But if it translates vertically, then it remains even. So that is kind of important to understand. I hope it is clear. Thank you.